everyone, welcome to this video. I'm Julida from Unimap. Today, I will present to you the project that I have created. My project title is IOT-based Smart Betta Fish Aquaponic Monitoring System with a fish disease prediction. What this project is about, I will explain it later. Given that this project is focusing on the betta fish and the seriousness of the water quality issue for the health of the betta fish, since the changes in the pH and also the temperature of water are related to the ammonia contents in the water, and thus are not visible by the naked eyes. As the result, a smart system for monitoring water quality in real time need to be created. For the purpose of researching and creating a high-effective water quality monitoring system for the betta fish, Changlun Betta Farm also collaborate on this project. My project has goals, and you can find them there. And now, let's turn our attention to the project methodology and also the result. You can find project overall flow here, but I will go into deeper on next slide for your better understanding. There are two primary phases in this project procedure. The first section is known as the experimental analysis section, while the second section is known as the fish disease prediction section. Several procedures were carried out as part of the experimental analysis to evaluate the effectiveness of the recirculating aquaponic system, or we know as the RASC in the terms of performance. In contrast, work is done in the second half to create an algorithm that uses MATLAB graphical user interface based fuzzy logic controller to predict the fish disease using water quality parameter. The two sections will then come together to provide an IoT-based smart aquaponic monitoring system with a fish disease prediction. This is project schematic diagram which labeled with the component that used in this project. On the next slide, I will provide an explanation of each sensor function.
TDS sensor function to indicate the total dissolved solids in a solution, usually water. Water temperature sensor used to measure the water temperature inside the fish tank. pH sensor helps to measure the acidity or alkalinity of the water with a value between 0 to 14. pH sensor calibration solution used to calibrate pH sensor. Here is how the hardware connection look like.
This is how a water quality monitoring system functions. You can find it in this project. As I mentioned before, this study includes both experimental analysis and fish disease prediction components. Let me now describe how the process was carried out in the experimental analysis section. First, a material investigation was conducted in order to choose the best material for the project. After that, set up the water quality monitoring device to gather the sensor data. Next, conduct the experiment to evaluate the RASC concept effectiveness. The experiment will run for two sets. One is without the RASC system and the other one is with the RASC system. 4 times daily sensor reading were collected over 1 week of each experiment. Let's analyze both experiment results. Here is the data collection table for the absence of the RAS system. As we can see, during a week, the value of monitoring sensor significantly increased. And this result in the death of one betta fish. The procedure was running same as the first experiment, but using water spinach as the hydroponic plant. Here, we can observe from the data collecting table that the parameters for the water quality are never outside of the range. That clearly shows how effective this strategy for maintaining the water quality in the betta fish aquarium. Done for the experimental analysis section, let's move on to the system for predicting fish disease. MATLAB Graphical User Interface or GUI-based fuzzy logic controller were used in this system to execute the operation. What is fuzzy logic controller? You can find the definition here. These are all fuzzy membership functions that's used to forecast the fish disease prediction. Without the fuzzy rule, fuzzy logic controller are nothing. The fuzzy rule with an established prediction goal is displayed in this figure. You can make as many rules as you like, but for this project, I will just make only 27. MATLAB App Designer was used to design the MATLAB Graphical User Interface or GUI to streamline the procedure. By just entering the value of the water parameter in the apps, the prediction process will be made simpler, and the system will automatically provide the result. Let's explore the efficiency of the MATLAB GUI. Here is the result of MATLAB GUI-based fuzzy logic controller in the fish disease prediction. As you can see, this is an IoT setup function using Link apps to allow users to track changes in the water quality parameter in the real time. Okay, let's see the result now. After years of work, we have finally developed an IoT-based smart aquaponic monitoring system with fish disease prediction for betta fish. The system flowchart can be viewed here. And this is how the system works. I try to apply this device in actual application. Let's see what is the result. See how well this device functions. The blink result instantly updates all the water quality parameters, and it also managed to tell the user of the current condition of the fish tank. Let me give you a quick summary of this talk as we near the finish of the video. The goal of this project is to build an IoT-based smart betta fish aquaponic monitoring system with the fish disease prediction. The lack of sensing instrument is the project main constraint. Additionally, this system is not intelligent enough to decide the future action for counter the current issue. So, what we can do to improve the efficiency of the system is by adding more sensors such as DO sensor and upgrade the system features. In that way, we can therefore enhance the system performance. That's all from me. Thanks for watching. Have a good day. Goodbye.